Okay, so good morning, good afternoon, and also good evening. So my name is Victor, and I'm going to be your anchor for this training. So this is part 5 of the CompTIA 220-1101, 220-1102 exams. So this is an exam that is meant for persons that are interested in hardware, persons that are interested in basic networking, PC setup. Cisco have this course as ITE, Information Technology Essential. So either you're trying to do cloud computing, or you're trying to do cybersecurity, or you're trying to go into core tech, or these skill sets are very, very basic, very, very important that you have them. Because if you want to do cloud computing, most of the things you're going to see as content, as skill-based learnings that you would see there, it has to do with hardware, it has to do with hardware. So have to do with networks. And these are the kind of things that helps you to lay the foundation. Or if you want to do cyber security, especially if you are doing asset management, you are doing digital forensics, you see that these concepts, these learnings are very, very key, very, very important in you understanding most of those advanced stuff, because there is nothing special, there's nothing new. No matter how high-end tech it is in technology, it's always going to be based on something. Like every device that you're going to see, every computer you're going to see is always going to have a motherboard, is going to have like a board, is like a circuitry, is going to have a CPU, is going to have all of that. So I think in 110, we have touched mobile, basics of networking, some of the protocols, which protocol are secured, which protocols are not secured. Because when you start doing cybersecurity, those are going to be your concern. But you need to understand the basics, then you now apply it when you now start doing cybersecurity. Then we'll touch a little bit about hardware. Later on, we're going to be looking at virtualization or cloud computing, because if you're going to do cloud computing, if you're going to do cybersecurity, you're going to be setting up virtual environments for most of your sandboxing, so for most of your test environment. Then hardware and networking troubleshooting. We touched a little bit of hardware, but later on in the course, we're going to look at network troubleshooting. Then in 220-1102, so basic operating system. In tech, we need to understand the different types of operating system as they pertain to mobile, as they pertain to desktop, as they pertain to tablets, as they pertain to embedded systems. Then, of course, it's very important for even somebody doing hardware, doing troubleshooting, to have some basics. So you have some basics of security covered here, though this is not a core cybersecurity course, but some of the fundamentals are going to be laid here. Then, of course, software troubleshooting and operating procedures. Okay, so if you are new to the channel, you can if you have questions, you can ask. If you're a student taking trainings, you can ask in the either WhatsApp or the Telegram group, whichever that is being used. And if you have questions, open to listening to you and replying them. Okay, so now we're in page 280. This is a book written by Mark Donald, all rights to him. So we're using this as our guide to summarize the entire CompTIA 2-module-based exam, or rather 2-exam-based certification. So we are in 220. So now we want to consider installing motherboards, CPUs, and add-on cards. What do you call add-on cards? So add-on cards are those guys, at times we call them extension cards. If a system does not have a USB or does not have sufficient USB ports, how do we extend? And most of the time, this is in desktops. If it is in tablets or is in mobile phones or is in laptops, you see them as like a hub or as an extender. If this is in a desktop, you are going to see a PCI or a PCIe card that you can put inside the computer. Once you add it behind the computer or in front of the computer, you can now have more rooms for USB. So it can be USB, it can be sound card, right? One of the reasons why you want to do this is that because not all, look at this one, not all systems are going to have all the features that you need or that you have. If somebody is going to be a DJ, that means that the person will need to have, let's say, 2-3 mics to be mixing on the software. Is going to have maybe two output to 2 speakers, 2 monitor speaker, and maybe one maybe feedback or something. So a conventional computer is not going to have that. Or at times a conventional computer is not going to have 5 USBs, right? You want to put in printer, you want to put in what was it called? You want to put in what again? You want to put in your internet, you want to put in maybe a phone, you want to charge a phone, you want to put in a normal laptop is just going to have 2 or 3 USB. Some recent laptops won't just have only one. They expect you to do what? Get a hub. So that's what we want to learn. We want to understand the motherboard, which is like the brain behind where all of these connections are going to go in. Then we want to see CPUs, central processing units, and want to see add-on cards. So everything on your computer connects to the motherboard. So what does the motherboard looks like? So your motherboard either is for a desktop or is for a laptop or is for a tablet or is for a phone. Every laptop or every device is going to have something you call the motherboard. So that motherboard is where everything you have on that PC is going to be connected to. So whether it's sound card, whether it's video, whether it's screen, whether it's audio,
connected to
whatever you have, right? It's all going to be connected to the motherboard. So let's understand the motherboard. So with different uses of computers, it follows that there are many different designs, right? If you say motherboard, Wikipedia, you can see the generations, right? You can see the generations of motherboard. So it's normally a printed circuit board. So it's like a circuitry. So see the history, the design, the very first ones, different form factors. Form factors have to do with is it a rectangle? Is it square? Is it for desktop? Is it for laptop? So that's what we call form factors. So the different shapes and sizes, right? Different shapes and sizes is what you call form factors. Then the CPU socket, where the socket is going to enter into. Then we have the integrated peripheral. So all of those devices that you're going to connect, from your floppy to your hard disk to your USB to your display port, your HDMI, all of those things are going to get into the motherboard, right? Then you have peripheral slot. Then a little bit text about temperature and reliability, because you see the motherboard is going to be working very hard. So most motherboards are going to have cooling system. I remember sometime in 2000 and let's say 6, 7, when I was doing my A+, you see a lot of computers had what we call mostly desktops. Then even laptops, they do have this it's a gel kind of cooling gel motherboard. Yes. So normally in different parts, something like this. Yeah, so you see, you have it or thermal paste, cooling gel, thermal paste. These are synonymous words. You see that because the computer, the CPU is going to be heating a lot.
Are you a professional looking to immigrate legally to the United States? Today, we're going to talk about one of the best. Is it better to use too much or too little thermal paste when building your PC? And
so the thing is that this thermal paste is going to be added before you now add the fan on top of it. So this will help the temperature. This will help in cooling. So this is very, very key when it comes to understanding the makeup and the build-up of a computer. Then
that's the paste you said is like the liquid from the back of the tree, those tree gums, right?
Come again.
I say the paste is like the one you mentioned in the video before. That is like those tree gums.
Yes. What happens is that the way this paste is now, once it starts heating up, it starts cooling. So that's how the paste works. So the heat, the more it is heated, it has a kind of a cooling feature, right? So that's how if you are, especially when you are cloning systems, people barely clone systems this way, but people still have need to like clone systems. Now, because the reason why people want to clone systems, they want high-end desktop or high-end servers or high-end machines. Most of the times, if you need to clone a system, you need to have the board, you need to get the CPU, you need to get the, sorry, you need to get the CPU, you need to get the RAM, you need to get the hard disks, you need to get a fan, you need to get typically everything yourself and you assemble. So knowing the makeup and build of a computer will help you understand how most of these things work. And also, if you are going to be making, if you're going to be coupling, you can also check on YouTube and say, a complete desktop computer
assembly
clone. Let's say we want to clone. So you could clone a complete desktop or clone a complete laptop. It then means that you just get, okay, clone here. What they mean here, clone is just like to make a backup, like a replica. So that's not the word I meant. Clone, I mean,
assembly.
Let's say build. Say build, assemble a complete desktop. Right? So basically, you're going to get all, okay, this is a 2 minutes video. Okay, let's watch it.
This is an entire PC assembly guide in a single video. There are 7 main PC components in a computer. You have your CPU plus cooler, your motherboard, your RAM, storage, graphics card, power supply, and case. When planning which components you want in your system, I recommend using a website called PCPartPicker.com to ensure compatibility between all of your parts. Now let's start by installing as many parts onto the motherboard before moving it into the case. With the CPU, locate the golden triangle corner of the processor and align that with the triangle corner of the motherboard socket. You shouldn't have to force this. The CPU should drop nicely into place and you can lock it down into the socket. Now many CPUs come packaged with a stock cooler that does have pre-applied thermal paste. If your cooler does not have thermal paste, you'll want to put a dot or a cross down onto your CPU before installing the cooler. Finally, don't forget to plug in the CPU cooler fan into the CPU fan header on the motherboard. Next up, RAM should be installed in dual channel whenever possible. Check your motherboard's manual for the recommended RAM slots to use. When installing, you'll notice a single gap at the bottom of each RAM stick. You'll want to align that with the single bump in each RAM slot on the motherboard. Align those two and you should be able to press down to click the RAM into place. Now let's install the motherboard into the case and start by inserting the I/O shield into the back of the case. Then you can place the motherboard on the case standoffs and screw it into place to secure it. This is a good time to install the power supply, generally in the bottom back of the case. Secure it with some screws and then let's do some cable management. The largest power supply cable is for motherboard power, installed on the right side of the motherboard. CPU power cable plugs along the top side of the motherboard. You'll also need to plug in a few things from your case, like the USB and front panel cables. Locations of these vary from motherboard to motherboard, so I recommend just checking the manual. Up next, let's install the storage, in this case, a single SSD. For this, we just plug in our SATA power cable, as well as our SATA data cable, and find a place to secure in our case. Last, but certainly not least, is our graphics card. For this, you want to install the topmost PCI Express slot. You should be able to click it into place without much force. Secure it with the screw and plug in the PCI power cables. With that, our PC is completely assembled, and if we did everything properly, we should be able to boot into BIOS to ensure that it's working. From here, the last step is installing an operating system of your choice. If you made it this far in the video, I'll let you know that I do have some Mr. Yeaster merchandise like this t-shirt on my website, MrYeaster.com. This video moved pretty quick, but that's because WordPress made easy as pie.
Okay, so that's just an overview of assembling a computer. So you're going to have all of those things connected on the motherboard. Okay, let's move on. Motherboard form factors. So by generations, like we've seen in Wikipedia, you have ATX, micro ATX, ITX, and MITX. So these are generations, right? From the old generations, most of the times they are bigger. As the generation gets more recent, they become a little bit smaller, right? So these are some of the features of each of the generations. So you have ATX and MATX, Advanced Technology Extended, CDA. You could ask ChatGPT and say, I want to know the different form factors. Sorry. You say, I want to know the different form factors, their advantages, their disadvantages, and their features, right? Give me my answer in tabular format. You're going to get a very nice comparison table. So this is what you have in your motherboard. So you have the CMOS battery, you have the front panel maybe USB sticks, USB ports, you have your SATA cable, you have your, I think this should be either the front disc or this should be the power. Then you have two, so you have the RAM slots here. No, PCI, this is going to go behind. This is going to go behind. So if you need to add more graphics card or you need to add more, what's it called? Let's say USB or whatever.
Expansion cards.
You can add it here to pull out. You see the view behind. There, this is your RAM. This is okay. This is the extension too. All of this section is extension. So this is where you have your RAM slot. This is where you have your processor sockets and slots. What do you have here? This should just be your heat sink. Then this is your I/O, your input/output devices. This is going to shoot out from the other side. So I think you have a summary here. PCI slots, they're all labeled. PCI extended slot. So all of these 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5. So 1, 2, 3, 4,
5.
5. Where's the 5? Okay, so typically 1, 2, 3 have your extension, right? They're going to go out, including this one. 1, 2, 3. So they are going to go shoot out for you to extend. Then this is going to be for your USB. Most of the times, the hard disks you are going to have on this system is going to be SATA. It's not going to be ID, integrated device electronics again. So it's going to be a SATA drive. So you can plug in the data here. Same thing with the DVD drive. It's going to be SATA most likely. So this is a little bit more recent motherboard. So you should be able to understand the motherboard and understand the parts. So this is another version. This is the micro ATX. So this is a little bit slightly smaller and maybe more recent. You still have about same items you have where you have your RAM, your hard disks, your slots, your I/O device, your RAM. This is your power, right? Number 7 is your power. Yeah, so this is a 24-pin power connector, right? This is a CMOS battery, number 12. This guy here. So one of the reasons why you need the CMOS battery is that the CMOS battery is going to hold configurations. It's going to hold things like the settings you have in BIOS. It's going to hold things like your time. So if you see a PC that the time is actually delaying or the time is no longer working, it then means that this CMOS battery is weak.
Okay.
So the CMOS battery is weak. The ITX family, so you see it's more recent. So one thing about the different generations of the motherboard is that as the generation gets newer, there's an increase in speed, there's an increase in more features, there's an increase in it being robust, there's an increase, most of the times the motherboard becomes smaller, right? So if you check this one now, so you see something a little bit smaller, right? So let me look for the RAM slots. RAM slot. I see the RAM slot. RAM slot is now smaller. This is the heat sink for the processor. This is that CD-ROM. This is your guys. This should be like a graphics display on board or your BIOS. Then this is your SATA stuff for your hard disks and your CD drive. Then I think this is where you're going to have your USB, your audio, your VGA, and whatever shooting out of the laptop. So you have a detailed description here for each of them for you to be able to identify them. Then comparing ATX, so for exams and for in terms of understanding, yes, for knowledge sake, understanding that their which one is better than the rest. That's why I said you could just go to ChatGPT and say different motherboard form factors for laptops and desktops, and you say, I want you to differentiate or compare them in terms of speed, in terms of size, in terms of features, right? That will give you like a summary of how to differentiate them and also compare them. Are you seeing? See the size? So size is a very, very important. Just like you have laptops, let's say 10 years, 15, 20 years ago, used to be a little bit bigger. Now you see laptops are getting smaller and smaller and smaller and smaller and smaller. You can even have an 11 point or a 12 point something screen laptop, a 13 point something screen, or a 14 point something screen. Before, you barely have that size. The minimum you have is like 15 inches, right? Then you have 17 inches. Imagine 17 inches as laptop. So it's like a what will I call it now? It's like a walk, a load on its own.
That's what we used to have those days, though.
Yeah, so
17, 15, 14.
20 years ago, you typically have only 15, 17 or 15.6. Those are the kind of laptops you had.
Yeah.
So, but these days you have 14, like the one I'm using now is 14.1. You have 14, you have 13, you even have 11 points. Very small
Mine is
laptops.
13.
Yes, yours is 13. So yours is smaller than my own. So most likely your laptop is going to be more recent than mine in terms of generation. So at times you can still see a series of laptop. They can do it in 15 inch for people that want a bigger screen. They do it in 14 inch and they do it maybe in 13 inch with some more enhancement. And you know, the more smaller it becomes, they are going to remove a lot of things. You cannot have all the ports that you need. No, they're going to remove some things. Like one of the staff in the office, his laptop, I think is that thing should be 13 point or 11 point. Now, there's no VGA, there's no HDMI, I think it's just USB. So if you need to use, let's say, you can do Wi-Fi, but if you need to do, let's say, Ethernet cable, then you need to just get an adapter, USB, you plug it, then you can add that, or you get an adapter. So the smaller the laptop, maybe the more features, then the less, what's it called? The less
Connectors and all that.
yeah, the less connectors and ports. Now, peripheral component interconnect. So this is PCI. So this is where all those guys are going to be connected to, right? So a typical motherboard is going to have where you can add peripherals. This is audio. This is USBs. This is VGA. This is USB, right? So how do you add all of the peripherals? You know, when we classify computers, we're going to say input, output devices. What are input devices? You say, what's it called? You talk about the printer, when you talk about peripherals, talk about the printers, the speakers, all of those kind of stuff. Those peripherals, how do you connect them? How do you interconnect them with the workings of the system through the motherboard? Right? So in 1992, you had that. So that way you have IOs, input outputs, so including network, video, audio, you can connect them to the computer, right? So this is it here. So you have 1, 2, 3, 4. So you see it's PCI extended 2. This is 1, this is 2. This is PCI X16 2. I think this should be the X16 1. So you can actually extend. So most laptops, most desktops, they are going to come and some of those ports empty. Now, one thing you should understand is that most of the times those PCI and even your USB provides you 5 volts. That's why you can charge. I've explained to you before now that if you open up your USB drive, your USB drive has 4 cables. Then you have data that is positive, negative. Then you have Earth, and then you have 1 power. So that power is what is going to supply these 5 volts. Then you have PCI extended. So you have version 1, you have 4, you have 8, you have 16. And this has to do with the IO lane. Very, very synonymous to their speed, how fast each of those ports are going to be. So they see the one that is 16 or 32 and the rest is going to be mostly used for things like graphics. And of course, the smaller ones can be used for typical USBs or audios. So the X refers to the IO lane. The most common versions are 1, 4, 16 designs. Most motherboards have 2 or more slots that use the 16 connector. However, the additional slot may have support for 4 and 8 transfer rates. So just understand that your different PCI versions will tell you what you can support, right? Are you seeing in terms of speed? What can you transfer? What can you what can you, especially take, for instance, if you want to transfer, let's say you need hard drive, you want to do graphics, that will tell, take people that are doing video recording, how do they, most of the times they're going to use a desktop, they're going to put in their video card, they're going to be doing live transmission, they're going to be, imagine you using a camera that is an XHD. Okay, what's more than XHD? So XHD is extreme high definition. So so you have FHD also. So most of these games, high definition, then you have SD, standard definition, depending on the pixel. I think we talked about these definitions in the previous class in terms of the video resolution and the rest. So imagine you streaming from a camera that is XHD, and once that camera is coming, the question is, your graphics card, how is it going to process that? So the bigger, the faster, the better. Okay, so that's one of the basic things you need to understand. Then you talk about power connectors. Like if you see the motherboard, how are you going to supply power? How are you going to connect power? In this case now, this motherboard is an older motherboard. So this is where the processor comes in. This is the RAM. This is the, I think this is IDEs, integrated device electronics. So one is going to take the CD-ROM, one is going to take the hard disk. So this is an older motherboard. So a more recent motherboard is going to have your SATA port. It's going to have your SATA port where, so what does the SATA port looks like? SATA port, motherboard. So that's typically, look at it. That's where your hard disk is going to enter. All right, so look at them here. So some desktops can even take up to 4 hard disks, especially those ones that are going to be used for servers or for use for backups and wherever. So you can have up to 3, 4, 5, 6 hard disks inside of them. So this SATA card is what is going to be used to connect them. SATA cable. So SATA cable, this your SATA cable looks something like this. So you will see some hard disks. Some hard disks are going to be, so this is the power side, this is the data. So if you connect this to a hard disk can now serve the computer via USB.
Okay.
So you have eSATA, so eFaster. So you see, like I always say, the more the more recent the version, one critical thing is going to be the speed, right? And what is going to be possible.
What's going to be what?
What is going to be possible?
Okay.
So most of the times, the interest is always, let's get more speed, let's get more speed, let's get more speed. Okay, processor compatibility. So most of the times, as you see each of the hard disks, you need to be looking at the compatibility to the what was it called? To the motherboard. So it's not all processors that can go on every motherboard, just like it's not all RAM that can go on all motherboard. Take for instance, if your system is, let's say, XGS laptop, if I got that right. XPS. Let's say your laptop is XPS. Now, let's say, depending on your version, let me say XPS 17, right? If your laptop is XPS 17, then there is a type of RAM that is always going to be compatible with that particular laptop. You cannot just go to the market and just buy any kind of RAM. No. There's also going to be a graphics card that is going to be compatible with that laptop. Same thing, memory cards. So it has to be DDR5, nothing more, nothing else. No shortcut. DDR5, which is very, very recent. In some laptops, of this XPS, you're going to have, of this XPS 70, you're going to have option of 16 gig or 32 gig. So that is 2 times, that is 2 slots. That means this laptop have only 2 slots. Some laptops 1, some laptops 4. Rarely will you see odd numbers. It's even difficult for you to see 1 slot, except for very, very old laptops. So you're going to see them in even numbers. So if you are using 2 slots, that is 2 times 8. That is 8 gig. You have 16. If you do 2 times 16, you have, if you have 32 gigs. So this laptop,
32.
the maximum this laptop can do is what? 64 gig.
64.
Yes, it has to be DDR5. You cannot use a DDR4 or DDR3 on this laptop. It's not going to be compatible. So for every upgrade, like you're going to be, I think in the curriculum, you also have troubleshooting, even hardware troubleshooting. And if you want to fix a system or solve a problem, technical documentation is very key, is very important. So there's always a compatibility issue between laptops and what kind of hard disks you can use on them, what kind of RAM you can use on them, what kind of display you can use on them, what kind of keyboard. You cannot just pick up any keyboard and you think it's going to work. So it has to be compatible to the series that the manufacturer. It's just like car tires. You cannot just pick. Some people are going to use a size of tire that is even bigger than their stuff. That one is even, but
not bigger than the rim.
Yes, bigger. Maybe same rim, but different width. And if you look at the car, you just ask yourself,
yeah.
You see the car is
that's true.
The car is just ugly, right? There's no balance. It's like it has a big bum and it has a small tiny wheels and that kind of stuff. So you need balance. So for laptops too, compatibility is a very big issue. So for you to even do any simple upgrade, you just check the laptop and look at for what is possible and what's not possible. If you are buying a laptop, if you want to do an upgrade, if you want to compare laptops, there is always, manufacturers have made it possible after the Windows Vista era, to make sure that, because before that time you had a lot of piracy. So after that period, so they now started making sure they provide enough information on their website, providing all of the support, providing all of the softwares on their site so that people can get, so that you're not waiting for one hacker to go pirate the software or pirate or have an abridged version or a hybrid version of what their customers are going to be using. Same thing for operating system, what can go Windows 11. Most of the time, that is what is going to come with, right?
Yeah.
Because that's about compatibility. So compatibility also applies to every other component. Same thing with the sockets, right? The CPUs that can go. Let me see for this particular laptop, the kind of CPU that it can take. Look at the processor. So this can take Core i7 and Core i9. So you cannot, it doesn't come in a Core i5. So mostly the build up or makeup of a Core i5 will not work for this laptop. This even has a caveat. So if you have to use this one, that means the graphics card must be this.
Yeah.
So if you're using Core i9, so that means it needs a higher graphics card. The graphics card that will work for this one is not going to be compatible for this. So many types of specialty CPU exist, along with the maddening number of code names. That is just replicas of different types of names. And keeping it also is difficult. Before you buy any CPU from the vendor, make sure that you are buying, what you're buying will work with what you have. Just like what I said. So you must make sure that you check the knowledge base, check the manufacturer site. You're going to see what kind of processors. You don't just go and buy. You can buy, it's not going to be compatible. Even with batteries on laptops can fit in, but are not compatible. Same with chargers, same with RAMs. Some of them can fit in, but they are not compatible. So that's why you need to check what best fits it so that you can know what it's going to work for it. So these are just different CPUs and the number of sockets. This is Core i5, for instance. So if you flip it, you see this notch. So when you turn this one around, see the code number, that is going to properly lap into this space. These are pins. So once the pin is not matching, if you try doing something else, you can damage this. Processor. So you have different what's it called, processor manufacturers. So Intel is one, AMD is another. So these are processor manufacturers. So you see this triangle. Most of the times when you are trying to fit in, this triangle is going to be also on the board. So you just trace it, and once you make sure it aligns, everything is going to fit in properly. So you have Intel processors, AMD processor, and most of the times when you hear the word mobile series CPUs, they're talking about laptops, right?
Okay.
So laptops are what we refer to as mobile devices. So compared to desktops that are stationary. So these are the cores, Core i9, the number of cores, the number of processors. Then you have the threads. In processor, there's what we call multi-threading, the ability to be able to perform more functions at a time, right? Multi-threading in processors, right? Multi-threading is a CPU feature that allows two or more instruction threads to execute independently while sharing the same process resources, right? So if you have older laptops, older CPUs, most of them are unable to do more things at a time, because if you give them more load that they can do at a time, they will just hang up.
Yeah.
So more recent CPUs are going to take care of that. So imagine you can have, like I'm doing this record, I'm doing this, I'm using my browser. I'm also recording. I can decide to be doing a live streaming via a port out. You can be doing several things, and they're going to use same resources.
Multitasking.
Yes, then they're able to do more stuff at a time. So the higher the number, the more stuff it can be able to perform. Now, servers, what do you call servers? So servers are just like computers, but they are special need computers. What did they do? Just like the word says server, so they serve. So that means they are designed to like actually perform more function than the regular computer. It then means that the computer is going to be looking up to the server for either information, for data, for network resources, for anything. Just like we say a network is two or more computers, two or more devices connected together to share resources. And that resource can be anything. Resource can be internet, resources can be files, resources can be emails, resources can be website, resources can be anything. So when you say a server will just be a computer that is going to actually function to work with other computers or attend to other requests, right? So a data center servers are specially designed for their main task of data retrieval and storage. Take, for instance, if you go buy, let's say 1 terabyte drive from Google, so that is going to be a system that is specifically like a file server. So you are going to be dropping file, your movies, your audio, your videos there on that particular site. So it's going to actually do quite a lot of work. And it then means that it needs a lot of resources. True or false? Because multiple people can be accessing it all at the same time. Okay, for mobile, that is for laptops and tablets and phone, you have different motherboard standards, and they are inches, right? You have mini ITX, you have nano ITX, you have Pico ITX, and you have mobile ITX. Now, basic input-output system and UEFI. So UEFI is the more recent one. BIOS is a little bit older. So it's a very essential component of the motherboard. It's the first code run by a computer when it is booted. So what it does is that it initializes all of the different items. That's what is called BIO, basic input-output system, right? So all of the different RAM, your memory, your CPU, that's why if your BIOS runs, it's going to present you information about basically everything. BIO, EU, FI. right? So it's something like this on your computer. When you boot up your computer,
Okay.
you have something like this, right? So EUFI, it's more recent, and most of them give you opportunity to be able to even use your mouse and click. This interface will always make sure that it is you can use your keyboard to navigate, right? So it might not be a GUI interface, but this might be a GUI interface. So EUFI is more recent. So you have how do you set up the basic input-output system, the RAM, the memory, the how do you set up the memory, the RAM? How do you see what hard disk space do you have? How do you see the temperature of the computer, the processor, and all of those kind of stuff? How do you see the time? How do you set up the time? So you need to get into BIOS. How do you get into BIOS? For different systems, you get into BIOS differently. If I'm using a Lenovo, let's say ThinkPad P16, get into BIOS, right? It's a very straightforward thing. They'll tell you the button to press. Power on the computer and press what? And repeatedly tap F1 when you're using Lenovo ThinkPad, ThinkStation, ThinkCenter, and this any of this logo is going to appear, and you get into something like this. You get into this environment, and you can now configure. You can set your time. You can see how much RAM you have. You can see all of those things even without getting to desktop. Okay.
Yeah.
So is that first program that runs initialize the components such as processor, RAM, video card, hard disks, optical drive. If there error occurs, it gives you the message. And you can also use it to do some testing. You can use it to test your hard drive. Some BIOS and UEFI have features for you to test your hard disks to see the status. Just like some phones, they can tell you the health of your battery, right? They can tell you the health of your, let's say, your screen. They can tell you the health of different components of your system. Some UEFI or BIOS can also do those functions for you. You can do that without even getting to desktop.
Yeah.
From this point on in the chapter, the term BIOS UEFI refers to both traditional BIOS and UEFI firmware, except when it differ. So how do you do configuration? So the system BIOS has default setting provided by the system or motherboard maker. So settings like time, settings like where should you boot up from when you first start your system. Like if you want to set up a new system, or if you want to format, or if you want to tell how a system should boot, should it boot from the network? Should it boot from your flash drive? Should it boot from your hard disk? How do you want it to boot? So all of those configurations, the only way to do that is through BIOS or UEFI. Now, another thing is also if you want to do set up things like virtualization. If you are doing cybersecurity, most of the times you want to install like virtual VMware, Oracle VirtualBox, all of those extended functions you want to do with your computer. How do you do those basic setup and configuration? You have to do that in BIOS. At times, you install a VM software and it tells you that this system cannot do virtualization. Please go to BIOS and set it up. So you need to restart and boot up the system and just switch the button on and activate virtualization. Then you can now install the software and do all of those kind of stuff. So like I said, how do you access BIOS? So depending on your laptop, some laptops is going to be escape when you are booting up. Some is going to be delete. Some is going to be F1. It's going to be F2. Like one laptop is F1. Some is going to F10. On older PCs, most of the times it used to be F2 and F10. But newer systems now give you option to do either escape or delete, depending on the manufacturer. Not necessarily new or old. So the manufacturer tells how you should access BIOS. If you access BIOS, it brings up a message like this. At times, your system is booting up and it's asking you if you want to enter into BIOS, press F1 or press F2, or if you're blah, 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 delete, all of this kind of stuff. From here, you cannot get into BIOS, then you cannot start testing out all of those setups. You can test that for your own system and see what the BIOS interface looks like. So this is what it looks like, BIOS setup utility. So it tells time. Like for instance, the first time or if the laptop is in a different time zone. And of course, you could do the time within the system. You just click here and you can set up your time. You can do that. But this gives you option to also set up the time for the BIOS. You can see how much RAM is installed, how many memory bank you have without opening the system. You can see that, okay, I have 4 gig total RAM. This is the type of RAM, PC3, 10600, without opening it. And you have only 2 banks. From here, you can also tell if you have 4 banks, if you have 5 banks, if you have 6 banks. I'm not saying 6 banks actually.
Okay.
Maximum is 4 for desktop. Most of the times for laptops, you just have 2. Okay, let me confirm if it's also possible. RAM slots maximum. Can we have 6 RAM slots? Modern motherboards at a minimum generally have dual channel memory with 4 slots. Each channel has 2 slots. High-end motherboards have 3 channel, 4 channel, and even 6 channel RAM. So I think 6 is possible. Let me see. So, but most of the time it's going to be maybe server or high-end stuff that's going to collect quite a lot of sticks. Okay, can do that as an assignment and check up and give us feedback.
Okay.
So there's another important feature you need to be aware of when you talk about boot sequence. So boot sequence, you can configure that in your BIOS. It tells what you should boot first when the system is actually booting up. Should you boot your laptop first? Should you boot your hard disk first? Or should you boot your CD drive first? Or should you boot your USB first? Or should you boot from your network? So once you get into BIOS, you're going to see boot order or boot sequence. So you can just toggle and select what you want to boot first. If you are trying to set up the system from a flash drive, then you select that so that once the system starts up, it boots from the flash drive.
Okay.
So you have things like boot sequence. Those are the kind of things you can do there. Memory configuration, you can see what you have. Your clock, your hardware monitor, your audio, your USB, your serial port, your parallel port, your USB function, you can enable. Take for instance, you have in some environment because of cybersecurity concerns and from BIOS, the USBs can all be disabled, right? It's possible to also do this from device manager, or you can use a device management software to do this. But just understand that when you're in BIOS, you can actually disable your USB ports, maybe all of them or a particular port, and you can also enable. Okay, these are some other features. Virtualization, I talked about virtualization, very important. If you are doing cybersecurity, either your S+ or your pen test certification, or any major entry-level, intermediate-level cybersecurity program, you are going to need to do Parallax, Hyper-V, Oracle VirtualBox, or VMware. For instance, myself, I have VMware, Workstation Pro, and also have Oracle VMware. So if you're going to do any of that, you need to activate virtualization if it's not already activated on the PC. If it is disabled, then the only way you can activate it is to come to BIOS. I think that's major items we have there. You can also password your BIOS, or you can also decide to say you want to activate it to actually detect infections that have to do with your boot sector drive. Okay, if you use automatic setup after you make manual changes, all your manual changes will be overridden. So this has to do with how your system boots, how your system works, some basic configuration you have in your system. So this has to do with boot sequence. So these are each of the items I just explained one after the other. So let me know if you have questions so far.
No, I'm good.
Now, some systems that BIOS you can update them, especially if you have issues. You have some systems that have refused to boot up. So you could some of the motherboards also have a jumper feature. A jumper is like a way for you to flash or you to reset the BIOS. So you see a system that is not booting at times is to change the BIOS, that chip, or to flash it if it has that particular feature. So that's one thing you should also be aware of, failed BIOS update, or where you're trying to upgrade the BIOS. Because that is like the, I won't call it the brain box, but it has like core basic configuration information about how your system should function, right? In terms of boot, in terms of time, in terms of configuration, major stuff, you have that in your BIOS. So if that is tampered with, that is affected, that motherboard might be as good as gone. So a lot of issues we have with motherboards, a lot of them are tied to BIOS. There's something called trusted platform module. So it's a way manufacturers can protect their device from you tampering it or like doing stuff. So at times you see there's this BitLocker feature in Windows. I think it's BitLocker. You have the feature, you can lock your hard disks, you can do all of those kind of stuff. So you call it trusted platform module, trusted platform service, where you want to manage your hard disks, manage that, and so that if somebody steals it, the person might not be able to use the item.
Use it. What did you call it again?
Trusted platform module. So trusted platform module is just like a service, a way to like protect a particular device. ATM machines, phones have the feature, like your phone now, you can, if you can, they will have a feature, either if you're using an iPhone, an Android phone, Samsung, most phones, they will have the feature that you can actually erase, wipe it, or if anybody tampers with it, right?
Yeah.
You can like disable the device. So it's like a trusted, or you can encrypt all the information there and they will not be able to like have access to it. Like you see now, if I turn it on, so I can now like protect these hard disks, of course, which I don't want to do.
Okay.
You also have secured boot that gives it, that makes it possible for you to like at times you could like password your BIOS. But understand that when you password your BIOS, that it's typically hard for you to get back once you forget all of those passwords. Okay, you have some settings here and some configurations. Depending on the what's it called, depending on the system, some of them have quite a lot of features. Battery charging, onboard audio, a lot of features. So for your laptop, you can check up and see what options that you have. Like I said before, now the CMOS battery is that guy that stores, it just looks like a watch battery. Like you have a most watch, this guy, normally 3 volts. That's what stores all of this information that we've been talking about all the while. Right? CMOS battery on the board. Are you seeing it?
Yeah.
So if you want to reset time, reset configurations, you just tap this, pull it up, wait for some seconds, pull it back, and all of those configurations are gone. So you have to start all.
Say that again.
I said, if you want to reset all of these configurations we're talking about, if you remove this CMOS battery, wait for some few seconds or a minute, it's going to reset. All of those configurations will be gone.
Oh, okay.
Same thing with like things like IP addresses that has been assigned to the MAC, that has been assigned to the Wi-Fi card or the internet card. All of those things will be gone.
So is that like do you now need to do any reinstallation all over again, or it just comes back to...
You're not doing any installation. You have to now reset. So you now have to reconfigure.
Yeah.
So let's watch the short
So
video.
it doesn't come back to like say factory default or whatever.
No,
Maybe you have your own reason, or you're just simply curious on how to remove the CMOS battery in your PC. CMOS battery location are different depending on what motherboard you have, but this is most likely located near your GPU slot or what we call the PCIe slot. For ATX motherboard and M-ATX motherboard, the CMOS battery has a battery slot like this. For mini ITX motherboard, it is located near the PCIe as well, but it looks different. The battery is covered in black plastic and it has a little plug that connects to the motherboard. To remove the CMOS battery on ATX and M-ATX motherboard, just simply push this lock and the CMOS battery will pop out. To place it back, just simply push the battery inward until it is locked in place. To remove the CMOS battery on mini ITX motherboard, just simply detach the small plug from the motherboard. To place it back, simply plug it the same way. There are a lot of reasons that's why some of us need to remove the CMOS battery. For example, if you have lose your monitor signal, or at times when you overclock your build and all of a sudden your PC stops working, or you see the reboot unselect proper boot drive on your display. Removing the CMOS battery for 5 minutes will give you a hard reset on your motherboard BIOS, and this will set everything to default. By doing so, your PC may start working again. This video is made for those who are doing basic troubleshooting in.
okay, did you get that? So that's how to that's what the CMOS battery is, and those are the kind of functions that it serves. So this is the guy here.
Yeah.
I remember when I used to network for where we used to have a lot of cafes, internet center. So one way to, you still had hubs, switches, not too intelligent switches and hubs. One way you have systems, for instance, that have refused to like get IP address, or they have IP address and they keep tripping off on all of those stuff, or they are having IP conflict and you have tried to reset and you're not getting through. One smart way to do is just to open up the box, remove the CMOS battery for like 1 minute, take it back, and all of those known configurations are going to be gone. Not with regards to your software, but with regards to things like your time, like your IP address, like your boot order, all of those things are going to be gone. I talked about encryption. I talked about trusted platform module. So you have what we call PC architectures. So you have different bits. That's somebody's going to ask you, oh, are you running a 64-bit or are you running a 32-bit? So most of the times the x68 architecture, we refer to it as a 32-bit processing computer. And most of them cannot do more than 4 gig RAM. It then means that their capacity, their speed, they cannot be able to process 4 gig volume of information at a time. So that's why if you install a 64-bit operating system on a 32-bit system, what will happen is that, or let's say, for instance, you have 16 gig installed on a 32-bit operating system, you cannot use the 16-bit. So you cannot use the 16 gig. You'll be limited to only the 4 gig. So if you want to enjoy that full capacity of the 16 gig RAM that you have, then you have to do what? Make sure that you are running what?
64.
Because 64-bit is more faster. It can do a lot of stuff. It's more recent, it's more new one. So this is about the comparison between the x84-bit, sorry, x66-bit and the x64-bit. So the bit processing is 32. You cannot do more than 32. This is 64. The maximum RAM this can take is what? 4 gig. Imagine the maximum RAM this guy can take.
Wow.
2 raised to power 64. So for high-end, look at what it can take.
Wow.
So no matter the speed that you or computer you're going to build that we are sure now for the next 50 years, If it's running on 64-bit, then so these are for older computers, right? Lower end laptops, lower end desktops. So you can use for gaming, for 3D rendering, for a lot of more recent stuff. So that's why if you install, like I said, 32-bit operating system on your laptops or your desktop or wherever, you cannot do more than 4 gig. Even if you have 16 gig installed, you'll be seeing usable RAM 4 gig. Just like if I check mine now, properties, are you seeing? I have a 20 gig, I have a 20 gig RAM installed, and I've been told 19.8 usable. So invariably, I'm using everything. You typically cannot use 100%.
Yeah.
So a part of it is just going to be reserved. So just like your hard disk, if you have 512 SSD, you cannot use 512. You'll be using, let's say 449 something thereabout. So, but if I was running a 32-bit operating system, right?
Yeah.
What will be written here is 20 gig installed, 4 gig usable. That's what they're going to be saying. So you should take note. So I think this section explains single core, multi-cores, when you have core 2, core 3, multi-cores, explain the concept of, what was it called? Multi-threading, being able to do more things.
Trading.
Yeah, to do more things at a time. If you open your task manager, you're going to see that how many things you are doing at a time and how the computer is coping to do that. Then virtualization support. So it's only recent systems that are going to do multi-threading. It's only recent systems that are going to do virtualization. Later on in the course, we're going to talk about virtualization and cloud computing, because if you're going to do cybersecurity, then you need to understand most of this concept, because this is what you're going to use. So virtualization support, virtualization is simply you being able to run more than one operating system on one hardware, right?
Yeah.
Virtualization. So this is what it looks like. So if you have to virtualize, you're going to have your hardware, which is my computer, for instance. I'm going to have my Windows 11, which I'm running. Then I'm going to have the hypervisor, something like Oracle VirtualBox, VMware, Parallax, any of those softwares, you install them. Once you install them, that means that you can have operating system 1, operating system 2, operating system 3. That means if you have Windows, with virtualization, you can install Linux here, you can install Mac, you can install mobile iOS here. So that is the advantage of virtualization. That's why it's called virtualization. Make believe, see a way to run what is not possible for you to run on the same hardware. Okay, anything important here? We've talked about expansion cards. Most of the times they come in PCI. So that's the guy that you can use to extend the current IO input and output devices you have on your computer. So when you say extension cards, and most of the time this applies to desktops. Most times applies to desktop. You don't have this in desktop. Most laptops are going to have, let's say, USB ports for you to now put, let's say, HDMI, or for you to put audio, or for you to put VGA, or for you to put audio, or for you to
I was about asking that.
Yes.
For the laptop, if you need to put an extension card, how do you now get the ports to come out if there's no port there?
Most of the times it's going to be USB to anything. USB to sound card, right? For laptop. So you are going to see, are you there?
Yeah.
See audios. Then you're going to see USB to HDMI. That is for video.
But that means you need to get a hub or something so that I can plug as many USBs.
If you need more stuff, you can get a three speed or 4-speed USB port, and you can put all of those things, and the system will be able to see them. But for desktop, you can have expansion cards, because you can put them through PCI or PCI extended inside the computer, and it's going to shoot out behind, and you cannot do anything you want. Look at this one. This is for a desktop. 1, 2, 3, 4, 5, 6, 7 ports.
Oh man.
Right? So we just that you can extend. So you call this an expansion card. If you put this inside the computer, you can extend, and you can see, you're able to have all of that.
So you need to, this one now goes to the motherboard.
Of course, now that's why it's called PCI, peripheral connect integrated. PCI, full meaning, peripheral component interconnect. So all of these guys get into the motherboard. Same thing with sound card, like I just explained. For you to do most of those things, you have to shut down the computer, right? Look for an empty slot, and you put it in. Are you there? Look at this guy. If you put it in now, behind, once you cover the case of the computer, it's going to be shooting out, and you're going to have the audio. This is this should be mic. Sorry, this should be earphone, this should be mic, and this should be like depending. Same thing with video card, right? If it enters behind now, are you seeing you have DVI, you have HDMI, which the desktop ordinarily does not have. But if it's for a laptop, all we just need to do is we say USB to DVI. Are you there? We plug this, and have this. Or we say USB to HDMI.
HDMI.
We plug this, we have this. Or we say HDMI to USB to HDMI, VGA, and let's say only these two. So we're going to see this guy now has both of them. So that's how you extend on a laptop. Are you there? So you can output this and this. And you see some of these adapters, they have options for this being an input or this being an output. So you have you have to be careful. You have to be watching to see when you are buying, whether it's like this one now, this is USB 2. So this is going to be sending signal out. It cannot take signal in. If you want to use it to bring signal in, so you are going to be saying HDMI to USB. That means you are taking the device as an input device. Very, very important. Because if you buy an output device and want to use it as an input device, it's not going to work.
Okay.
Yes.
So you need to be sure of what you're buying, which one is input and which one is output.
It's written. You will see it on the body of the item when you are buying it in HDMI to. That means that you should be plugging that one to a HDMI port on your laptop. You cannot be sending to VGA in case you have a VGA projector.
Yeah.
Same thing the other way around. Okay, anything important here? Capture card, especially for guys that are into broadcasting, YouTube, all of those stuff. It then means that they want to collect video, or at times some of them want to send out video, or they want to record. You are streaming from YouTube, so if you send it out from a device, once it's coming into the laptop, you now want to record, or you have it as a program, as a training, or in church, or a program, or a service, or an event. As the person, as you are recording from the camera, as you are picking it as output into the computer, then you want to be capturing. So it's going to be a graphics card. That's going to be a capture card, right?
Okay.
To look like something like this. Sorry, not this. Look, I think it's not drawn. but just like every other example I have given. So this is heat sinks. You normally see this on top of the laptop.
I'll check ChatGTP for the picture.
Yeah, so this part, you now have a fan on top of it. The fan on top of it is now going to help in cooling. So this is like multiple ways to guarantee cooling, right? Multiple ways to guarantee cooling so that the processor, so you see the heat sink, you have a fan here, then you have a pipe. This pipe will draw the heat out and we pull it up here. Let me just get a clearer picture. Heat sink laptop, sorry, let's say desktop with a pipe. Are you there? So at times in some laptops, if you open them, you see something like this. So these pipes are meant to just pick up the heat and send them away. So that's why if you touch the side of your laptop, you're going to be feeling this side. So if you touch this side, you're going to feel in hot air. So this guy is drawing the heat from the processor. The processor is here, drawing it out and sending away. So those are the pipes, and this is the heat sink.
Yeah.
Okay, so you have some laptops that don't have fan. Some have, depending on the configuration. So each manufacturer will tell whether they need a fan or they just need a heat sink, right? So it all depends. Like this one, now there's no fan. It then means that this is capable of providing cooling. This one too, there is no fan. It's have option of providing cooling. Look at this guy. This guy has heat sink and a fan all together. This guy, heat sink and a fan. And this is going to be a very high-end computer because the guy is going to be generating a lot of heat. Right? So most of the times it just depends on what the manufacturer based on testing. They've talked about liquid-based cooling, right? So just that small base that you have to provide cooling. So these are just ways to make sure that there is cooling at the end of the day. Okay, I think we're going to call it quit today here. So in the next class, we're going to begin with power supplies.